Okay, so in the last video we said linear searching. Dude, just write it nicely. Linear searching an unordered array, okay, of n values means in the worst case we have to search through n things. Okay? Now let's say we played this game again and we said I want to have I want to find out if I have a row of pixels, okay, and I want to find out if any of these pixels have a red value of 10, a blue value of 25, and a green value of 50. Okay? And so we start going through these pixels, and we want to see if that's the case. All right? If any one of these has that. And so for each pixel, we have to check the red, blue, and green values. Sorry, red, blue, and green. I don't know why I did it in that order, right? And then we go to the next one, and we have to check the red, blue, and green value. And then we go to the next one, and we have to check the red, blue, and green value. Okay? To see if that's the case. In the worst case scenario, we're going to have to check 3 values in every box. Okay? So in the worst case scenario, we have to come all the way here, and we have to check 3 values. Now, some of you might be saying, well, we don't necessarily have to check 3 values if red's like 5 or something. But if all of these have a red, worst case scenario, right? A red of 10 and a blue of 25, we're going to end up checking 3 values. And we go all the way to the end. So we have n pixels, okay? And the number of things we have to search through is 3 for every n, right? For every single one of these, okay? And it's kind of like an unordered array. There's no rhyme or reason as to what pixels are going to be where, okay? And so we get to the point where we're like, well, n is the space, it's the total space of things, right? And we're going through, so n is our total pixel values, and we have to search through 3n things, okay? And really, so if the number of pixels increases, right? Because we're talking about pixels here in this algorithm. So if the number of pixels increases, we have to search through 3 times as many of those pixels, okay? So we end up having to search through 3n, all right? So in this case, if our space is n, we search through n things, right? And we decided that was this nice linear relationship. And if the number of things we're searching through is n, the number of things is n, we end up having to search through 3n. So if we're going to plot this one on this, it would be like that, okay? Now, the important thing to notice is that these things look different, but in terms of big O, we say that they both have a linear relationship. Okay? Or, to put it another way, both of these algorithms are a linear runtime algorithms. Okay? They're the same algorithm, but in both of these situations, they're this linear runtime. Okay? Or maybe it's slightly different. Anyways, the point being that they have this linear relationship. As n increases, the number of things we have to search through increases linearly. Okay, notice there's no curve here. It's linear. Anything that's a scale or a shift, so 3n plus 5, will still be a linear relationship. What's an easy way to detect this? Well, you look at this and you just find out what's the highest order. Okay, in this case, the highest order is n, and so we say that these two algorithms, even though you're searching a different amount of things, are both O of n. That is, as the number of things increases, the number of things we have to search through increases linearly, regardless of how linearly that is, right? If it's regardless of the slope of that line, not how linearly that is, but regardless of the slope of that line, okay, it we're going through it linearly, okay. A few questions, and then I'll see you next video where we'll talk about some other runtimes that are important.